All right, so what's going to be different about this particular day versus addition and subtraction is now we're going to pull in fractions. In 7th grade, we work with multiplying and dividing fractions a lot. That in decimals is where we're going to live. Good news is it's way easier than adding and subtracting fractions. So although we're adding another element, I hope that you find today still not any more difficult. We're still going to break it down into those categories. So the first thing I want you to write, eyes up, journal open, please, is integer rules. Multiplying integers, or just put integer rules. There's the word integer. And again, we've broken it down into those sections so you can refer back to those separately. And at the end is when we're going to put it all together. And it's pretty simple. The only thing that I want you to write is that triangle. I want you to think of this triangle as your calculator. I know if I ask you, would you like to have a calculator every day in class, you would all raise your hand, right? Most of us would. This is your integer calculator. It's going to calculate for you without having to memorize anything, the sign of your answer. If you can remember how to draw it, then you're going to have it. Super, super simple. And I'm not even going to talk about it until we get into the problems, and I'm going to model for you how it works. Deal? All right. Come on. Let's start with an easy one. Let's start with negative 8 times 4. Write that problem down. Negative 8 times 4. All right. First thing I want you to do is just multiply those two numbers as if the negative sign was not there. So what is 8 times 4? 32. Pretty simple, yes. Then I'm going to think about that little triangle. That's my integer calculator. Only works with multiplication and division. Eyes up and watch me. So my first number was negative. My second number is positive. And what does that leave? What symbol is uncovered or unhighlighted here? Negative. So that tells me my answer is going to be negative. It's that simple. If I were you, instead of coloring those in, I'm using my handy dandy fingers. I've always got those. So I'm covering up the signs of what's in the problem. So I have a negative and a positive. What's left showing? Negative. If I have a negative and a negative, eyes up, watch. A negative times a negative makes a positive. It works every single time. Whatever's left showing is the answer. Now, the one that's not there is positive. But hopefully, because we've been doing that, positive times a positive is always going to be positive. I don't need to do that one. I know that one. The other ones, and I don't have to memorize how the grid's filled in, nothing. Draw the triangle, cover up the two that are in the problem. The one that's left is your answer. Love that little tool. All right, you do the one underneath it. You do 9 times negative 7. Now, I am going to write this a different way. I'm actually going to write it 2 different ways. So this means the exact same thing as the problem above it, where I put both of those values inside parentheses. The 2 parentheses stuck together with nothing in between always means multiplication. The other way that you're going to see me write it more than using the little X is like this, with a dot. All 3 of those mean the same thing, and you have to get used to seeing all of those. So I'm going to draw my handy dandy triangle again. I'm going to multiply 9 times 7. What's 9 times 7? 63. Then I'm going to go to that handy dandy calculator, my triangle calculator. I have a positive times a negative. What's left? Negative, so I know my answer is going to be negative 63. Feel good? Let's do one more. Last one that we do. I want you to write this different, okay? Write this the way that I do. Write both of those values inside the parentheses, but don't put the multiplication sign in between. They mean the same thing, but because we'll be moving into equations pretty quickly, and most of the time our variable is x, we move away from using the x as the multiplication symbol. All right, so I'm going to multiply as normal like the negative symbols weren't there. So I want you to multiply 24 times 3. I want you to multiply 24 times 3. If you have not already done that, I want that pencil moving. I'll do it for you sometimes. Sometimes you got to do it. Wilbert, did you get it? What? It helped me out. So 4 times 3 is, carry over my 1. 3 times 2, 6 plus 1, 7. You're good. Okay, now I've got to think. Using my handy dandy integer calculator, I'm going to go back to that highlighter. If you have colored pencil or highlighter, these things help you. The way I color code will help you. I have a negative times a negative. So that's going to leave a positive. So my answer here is just positive 72. Does the triangle make sense? You don't have to memorize the tic-tac-toe board or anything like that. Just the little triangle. Anybody seen that before? Yeah, I like it. Hopefully you've seen it before. If not, I'll learn you. All right, so new section. Let's transition to fractions. So our fraction rule is simply, and I want you to make this look like a fraction. This is a fraction. Top, so we're simply going to multiply top times top, bottom times bottom. Top times top, bottom times bottom. Now, what's going to be a little bit new, probably for most of you, is how I reduce and simplify. You know that's that golden rule of fractions. We have to simplify our fractions, right? Yes? Okay, so instead of waiting to the very end, when I have these big numbers, I'm going to do it before I multiply. And the numbers are smaller, and it's way easier. So I'm going to model that for you as we go through all the different types of fractions. So let's start here. 7/10 times 2/3. Write it. I write, you write. So let's talk about numbers for a second. When I multiply 7 times 2, what do I get? 14. The two factors of 14 are 7 and 2. So these numbers are simply factors, numbers that I multiply together to get these. So what I want you to do is I want you to look right here at all 4 of those numbers and look for a top and a bottom that will reduce. Do you see a top number and a bottom number, doesn't have to be on fraction, that will simplify? 2 and 10. I don't want an eraser. A highlighter. There we go. So I'm going to color code those so you can see them. What number will go into, divide evenly into both 2 and 10?
5.
That's what I get, what goes into it. You're right. How'd you get 5?
You divide by 2.
Divide by 2. 2 goes into 2, yes. 2 goes into 10. Everybody shake your head, yes, because it does. Okay, there we go. 2 will go into both of those. How many times does 2 go into 2? 2 goes into 2 one time. So I'm going to make that a 1. How many times does 2 go into 10? 5. All right, now I'm going to look again. 7, 5, 1, and 3. Do you see a top and a bottom that will simplify now? Will 7 and 3 reduce? Does 3 go into 7 evenly? No. 1 is as small as it gets, so 1 and 3 won't. 7 and 5 don't. So that is completely simplified. Can't get any smaller. And when I multiply, it's not going to reduce. So let's multiply. So now I'm going to multiply top times top. The 7 times the 1. What is 7 times 1? 7. Okay, now I'm going to go to the bottom. And I'm going to multiply 5 times 3. You have to keep that work neat. What is 5 times 3?
15.
15. And look at that answer. It doesn't reduce. It's 7/15. The other way that most of you were taught was simply to multiply top times top, which you get 14. and 10 times 3, which is 30, and then I reduce. And guess what that reduces down to? Guess what this reduces down to?
15.
So there we go, 7/15.
Because you divided by 2.
You divide by 2. Now, on this one was fairly simple, but most of the ones that we do as we go through the year get much more complicated. They get really, really big. And so it's much easier to do it at the front, and I want you to practice it. All right, different type of problem. Now I have 8/10 times the whole number 16. I write, you write. Let's go. Every one of these we're going to do. Remember, keep that journal nice and neat. 8/10 times the whole number 16. Now, my rule said I need a top times a top and a bottom times a bottom. I ain't got a bottom to 16. So I got to fix that. So, you guys in the back, somebody said it. What do I need to do with 16? Put a 1 under it. You guys turn around and look at the back. Turn around and look at the back. Look at Invisible Math. Look at the posters in white. Okay, so there is a denominator of 1 for every single number. So the verse of that is if I have a whole number and I want to make it a fraction, just stick a 1 under it. Works. Same thing. So I'm going to change my problem to 8/10 times 16 over 1. Now I have a top and a bottom and a top and a bottom. Everybody with me so far? Okay, now I want you to look to reduce. Can you find a top and a bottom that will reduce? Okay, where? Okay, but it's got to be a top and a bottom. Yes, those do, but that's 2 tops. So where's another pair?
16 and 10.
16 and 10. Anybody see something else? 1 doesn't get any smaller. There's one more place. So 16 and 10 is a yes. Do you see another place?
8. 10 and 8.
10 and 8. So you have a choice. Now here's my suggestion. Eyes up. I would pick the 2 biggest numbers. Okay, so I am going to do 10 and 16. So what's the biggest number that will go into 10 and 16?
4.
Will 4 go into 10 evenly? Nope, that won't work. Will 5 go into 16? No, that won't work. 2 goes into both of them, right? Okay, 2 goes into 10 how many times? 5. 2 goes into 16.
8.
There we go. Now I have 8 and 5s. 8 and 5, those aren't going to reduce, so we're done. Now we're going to multiply top times top, bottom times bottom. And I'm going to color code it for you so you can see where it's coming from. 8 times 8 is what?
64.
64. Got my equal sign. 64. What's 5 times 1? 5. Now, at one point in the year, later on, not today, that's going to be a great answer. We're going to leave it just like that, but we're not there yet. So what do we got to do with that improper fraction where my top number's on bigger on top? We don't want to leave it like that. What do we do?
Simplify.
How?
Divide.
Divide. This bar simply means divide. So we're going to take 64 and divide by 5. I write, you write. Do all this with me. If you just write the answer, when you go back, you're going to go, I don't know how she got that. How many times does 5 go into 6? Once. Little division for us right off. 6 minus 5? 1. Bring down the 4. 5 goes into 14. How many? Twice. 2 times. Because 2 times 5 is 10. Subtract, and we don't have anything else to bring down. So let's talk for a second. My denominator here is 5. So my denominator is going to stay the same. It's still 5. So this little remainder gets to jump up here and become my new numerator. If you'll remember denominator stays the same, it will help you. So our final answer here is 12 and 4/5. Whew, that's a lot, right? A lot of little steps I got to remember. One more type of problem. 2 mixed numbers. Write this down. 4 and 5/7 times 2 and 1/2. My rule for multiplying fractions is I need a top times a bottom. I don't have that. So I got to change it. I need a single numerator and a single denominator. So how do I change that mixed number? We'll start with 4 and 5/7 into an improper fraction. Give you a hint. Make this a little smaller. So yes, a lot of your teachers called it what? Walk around Texas, right? But when we walk around Texas, we are really changing a mixed number to an improper fraction. So we're starting with 7. What am I going to do with 7 and 4? It's great if we know the name of it, but if we don't know what we're doing, it doesn't help us. Multiply. I write you right. I write you right. What is 7 times 4? Write it down up here. Okay. Now I'm going to take 28, and what am I going to do with that 5? Who remembers? Add. We're going to add them. So 28, 29, 30, 31, 32, 33. So that's my numerator. Denominator stays the same. So my denominator was 7 up top. It's going to still be 7. All right, same thing. To 2 and 1/2. We're going to multiply 2 times 2. 4. I would highly encourage you to write that down. Okay, just like I have. And then we're going to add 4 plus 1. Denominator stays the same, which is 2. So now I have a top, now I have a bottom. Do you see a place that will reduce? No, 33 is odd. Will 2 go into it evenly? No, so that won't work. 33 is actually 3 and 11 are the only factors of that. I don't see a 3 or 11. Well, 5 and 7? Yes, no, no. So that's it. We're done. We cannot simplify here. So all I'm going to do is multiply the top times the top and the bottom times the bottom. I'm actually going to do the bottom first just because it's easier. What is 7 times 2? 14. Now all I have to do is multiply the 33 times the 5, and I don't have that memorized. And I'm a visual person, so I'm going to write it down. So are you. 5 times 3, 15, carrier 1, 3 times 5, 15, plus 1, 16. Remember what I said? We cannot leave it as an improper fraction. So what does that little bar mean? Divide. Woo! All the steps. This one isn't hard though, so don't freak out on me. How many times will 14 go into 1?
0.
0. And he said it exactly right. Most of the time we say it won't, right? But when we say it won't, mathematically, I want you putting a 0. Excellent job. Pre-AP didn't even say that. I want a 0. That will just transition you into when we're dividing decimals that everything's lined up. So right now, put a 0. How many times will 14 go into 16? Once. Let's see if I can do this right. I made a mistake first period. 16 minus 4 is 2. Bring down my 5. 14 into 25.
Once.
Just once. We can check 2 just to make sure, but 2 times 4 is 8. 2 times 1 is 2. That's too much. So yes, indeed, it's only going to go once. Subtract. What's 15 minus 4?
11.
Well, 1. And then 2 minus 1 is 1, and we get 11. Yes. Okay, I want you to write the fraction part of this. If you haven't already done so, make your fraction part. Remember, the denominator stays the same. So our denominator was 14 here. It's going to stay 14, and 11 becomes my new numerator. Whew, that was a lot. Good news is we're done with fractions for a minute. Okay, that's all the different types of fractions that you will work. Similar numbers. I was thinking, is that the exact same problem? Okay, write this one down. If you want to go ahead and write it to work it, I'm okay with that, but make sure you include the negative. So negative 3.65 times positive 8.2. Do I need to line up the decimal point? Nope. Multiply like normal, ignoring the decimal point and negative sign. So 2 times 5, 10. 2 times 6, plus 1, 13. 2 times 3, 2 times 3, 6, plus 1 is 7. So I need that place value holder because I'm moving to the second digit. Eyes up, please. Now I'm going back to that first number. So 8 times 5.
25. Wait, no, never mind.
40. You're good. It's been a while since we haven't multiplied, right? Ooh, this is a hard one to remember. 6 times 8. 6 times 8 is 48. Well, I got to say it to remember. 6 times 8 is 48. All right, so 48 plus 4. So 48, 49, 50, 51, 52. 8 times 3, 24, 25, 26, 27, 28, 29. Add her up. 0, 3, 7 and 2, 9, 9 and 2. Just a lot of copy in there. All right, I want you to do the decimal point. Count the number of decimal or digits to the right of the decimal. Underline them as you count them. Physically, I want to see that on your paper. Underline all the digits to the right, counting them. Then grab that decimal in your answer and move it to the left. 1, 2, 3. Start here. 1, 2, 3. Now, when I write my final answer, I am going to drop that last 0. One last step. I'm going to draw that little calculator every single time. I have a negative times a positive, so my answer is going to be negative. And you know from when you graded yesterday, if we forget the negative sign, it's wrong, right? We've got to pay attention to the sign. All right. All right, let's do one fraction where we mix in the positives and the negatives. I'm going to rewrite this so it makes a little more sense. Do this with me. Again, I want you to get used to seeing it inside parentheses. Make sure we're writing, please. Keep those notes nice and neat and logical. Have a pencil. Should be taking notes in a pencil. You can keep that for now, but from now on I want a pencil. All right, so step number 1 is we're looking for a top and a bottom that will simplify or reduce. Do you see a top and a bottom that will simplify? 4 and 16. Okay, what goes into both of those? 4. 4 goes into both. Okay, 4 goes into 4. Once. 4 goes into 16. 4. All right, so I'm looking for a place that will simplify. Is there any numbers left that will reduce? Okay, so now we're ready. Top times top. Top times top. Get 7. Bottom times bottom. 20. Last thing is our little calculator. I have, let's see, a negative times a positive, so my answer is going to be negative. So I have a negative 7/20. Good news is on your independent practice, eyes up, this is the way most of your problems are going to look. I don't think I threw any mixed numbers quite yet. All right, so that's where we're going to live for today. Let's talk decimals. I am going to have you write the rules out, but I'm going to kind of abbreviate this for you, okay? So do this with me. Write decimals, decimal rules. And I'm going to highlight what I want you to write. So step number 1, I want you to multiply, ignore the decimal. That part I want you to write out. Ignore the decimal. Just multiply like usual. Multiply normally. You could write that. That's probably pretty simplified. We'll probably have to write most of that. After you're done multiplying, you are going to count all the number of the digits to the right of the decimal. Count them all out. All of them. Both those numbers that you just multiplied, all the numbers that are on the right, we're going to count them out. And then, yep, in your answer, this is about as simple as we can get it. In your answer, you're going to move the decimal to the left, that number of places. Now, cool thing about these two examples is they've already started incorporating that positive and negative values in. So we're going to start to combine those right off the bat. We're also going to ignore our integer, the positive and negative sign, till the very end. We're not going to do anything with it until the very end, and we'll pull in that triangle. Make sure you have all of that written down. The more we write it, the more we remember it. It all gets written down. And we're going to work 3.47 times negative 2.4 first. Notice when I write that problem that I am not lining up my decimal point. Don't need to do it. If you do that, you're causing yourself more work. So just write it down, ignoring the decimal point, just like you normally would. And we're just going to multiply like normal, ignoring the sign, ignoring the decimal point. All right, starting with the 4. 4 times 7. Hello. 4 times 7. 28. 4 times 4. 16, 17, 18. Carry over my 1. 4 times 3. 4 times 3. 12 plus 1. 13. Highly encourage you to erase those numbers that you just carried over. Get rid of them. They will confuse you. Now we're moving to the 2. 2 times 7. Notice what I filled in. What do I have to fill in this first place?
0.
My 0. It's that place value holder. It's just keeping things lined up. 2 times 7. 14. Carry over my 1. 2 times 4.
8.
Plus 1. 9. And then the last 2 is 2 times 3,
6.
which is 6. Now we're going to add it all up. 8 and 0 make 8. 8 plus 4 is 12. I see 9 and 1 makes 10. Plus 3 is 13. And then 6, 7, 8. Okay, so we multiplied like usual. Okay, what's step number 2? Count all, what does it say? Count all the digits to the what? To the right. Okay, eyes on the screen. I'm going to do it, and then I want you to do it. Eyes up. So every number to the right, I'm going to underline. So 1, 2, 3. I count all the numbers to the right. That's this side, to the right of that decimal point. And there are 3 of them. Then step number 3 says, okay, now we're going to go down to our answer. And we're going to move left. So starting over here, I'm going to move it the same number of places. Watch me. 1, 2, 3. I have one more step. Last step is to think about my integer rule. Okay, in our problem, we had as up a positive times a negative. So what's my answer going to be? Negative. So negative 8.328. How are we feeling? Good? Let's do a couple of word problems so you can just kind of see how these multiplication problems are worded. Eyes up. Oh, we love some submarines, climbers, and temperature. They're all about that. A submarine dives below the surface, heading downward in 3 moves. Okay, so let's visually. Try here. Dives down, stops. Dives down, stops. Dives down, stops. 3 moves. Everybody with me? Okay. Then it says if each move downward was 325. Okay, so let's talk. If I'm going down, what sign represents down? Negative. So I am going down negative 325 feet. And each one of those moves is the exact same distance. Each one. So what's one way I could work it? 325, 325, 325. Right? I could add all of those up. What's another way?
Or you do times 3.
We're multiplying, right? So we're going to times it times 3 because each of them are the same. All of them are going to be this repeated situation. Each, every, repeated. Those are my code words that says, hey, this is a repeated addition problem, which I probably need to work as a multiplication problem. 3 times 5.
15.
3 times 2 is 6 plus 1, 7. 3 times 3, haven't done that one yet. Okay. Here we go. I have a negative times a positive, so my answer is going to be negative. So the question says, okay, after he finishes diving, he is at negative 975 feet. Then you could say, yes, feet below surface level. This is one that actually came from your independent practice. It's on that page. You're not obviously going to do it, but it's some that's one on here. So Greg sets his watch for the correct time on Wednesday. Exactly 1 week later, he finds out that his watch has lost 3 1/4 minutes. What's the overall change in time after 8 weeks? So each week, again, it's the exact same time that I'm losing. If I'm losing it, is it positive or negative? So let's change colors. Negative 3 1/4. And that's happening 8 times. 8 weeks. So I'm simply multiplying by 8. So we got to walk around Texas because I need A top and A bottom. Four times 3. Slade, you with me? Make sure you're with me. Okay. 12. And then I'm going to add 1. 13. Fourths. And remember to take that negative down with it. Okay? What do I need to do with that 8? Because I need a bottom number.
Give it a denominator of 1.
Put a denominator of 1. Ooh, you said it fancy. I need the bottom to be 1. Stick a 1 under it. Whew. Now I gotta look. Is there a place to reduce? All the steps.
8 and 4.
8 and 4. We've done this one. How many times will, we'll just say it, 4 go into 4? Once. 4 goes into 8. 2. Oh, I love when this happens. This is awesome. We love when they're all 1s on the bottom. Makes it super simple. top times top. 13 times 2. Oh, not a highlighter. 1 times 1. Okay, now, this is going the opposite direction. So we stuck a 1 under 8, but now I have a 1, and what do I want to do with it? Well, how many times is 1 going in 26? 26. We know that, right? I don't have to. When I see the 1 as a denominator, my answer is simply going to be 26. Now, I have one more step. And again, I save it for the end because that's the way my brain thinks about it. You may want to do it at the very front, but you got to make sure you remember to pay attention to your integer rule. And we have a negative times a positive, which makes a negative. We just crammed about a whole 6 weeks worth of work into a day. You guys took your time really studying it. I'm gonna pause.